would be if I'm starting from rest, moving at a constant speed, 4.5 meters at 3.5 seconds. Let's find out. Doing the calculations, I came to find out that, and there we have it. With my displacement being at 4.5 meters, initial velocity at 0, followed by constant acceleration, I was able to use the equation Vf squared equals V initial squared plus 2a delta x. Knowing that my initial is 0 allowed me to exit out of the equation, as you can see right here. The acceleration came to be 9.8 meters per second and a delta x of 4.5 meters. You see right here. Multiplying the right side of the equation gave me 88.2. Squaring the 88.2 to get it to equal Vf left me with 9.39 meters per second as my final velocity. Well, that's all today, folks. I hope you enjoyed our news report on kinematics. Now you can find the final velocity of any object. Now that you know all you need is displacement, initial velocity, time, and or constant acceleration. Take notes. Kinematics can help you in any situation physics-wise. Have a good one.
Forces are loosely described as a push or pull, and normally they have either a contact force or a field force. A contact force is a force that needs two objects to be touching. A field force is a force that you feel without touching. With forces, there's a force applied, this way, if I push. There's a force of gravity, downward. There's a normal force pushing back up, and there's also a force of friction, this way. And here's my math. I wrote down that I'm moving at a constant velocity, so that means there is no acceleration. And between these two surfaces, as they move, the kinetic force of friction is 0.23 mu.
Hello everyone, and this is Physics with Donnell Boney. Today's topic is projectile motion. And basically, projectile motion is the free fall of an object with horizontal velocity, which I will demonstrate by tossing this ball. Alright, in the previous video, you witnessed me drop a ball from approximately 1.5 meters high, and it traveled a horizontal distance of about 1.2 meters. The equation I am about to present you with has absolutely no air resistance in it at all, mainly because of the current environment we're in. Now is the physics part. First we start with a vertical column and a horizontal column. What we already have is that the vertical distance traveled from the ball's starting point to end point is negative 1.5 meters. And the acceleration we know, because gravity is acting on the ball, is negative 9.81 meters per second squared. And we already know that the initial velocity, because the ball was starting at rest, is 0 meters per second. What we want to find is the V final and time. And also in the horizontal column, what we need to find is the horizontal velocity of the ball. And what we have is the total distance traveled horizontally from the ball, which is 1.2 meters. And what we also want to find in horizontal column is time. So first we start off with our directions. Going upward, I have y as positive, and going right, I have x as positive. So that makes, because the ball was traveling downward, that makes this 1.5 meters negative, and gravity 9.81 meters per second squared negative. So we start off with the equation of y distance equals initial velocity times time plus half times acceleration times time squared. And we formulate that by plugging in your answers, and we get 0.55 seconds. So we plug that in here for time, and here for time. And we also want to find V final on the vertical side. So we start off by plugging in what we already have in the equation of V final equals V initial plus acceleration times time. And we plug in 0 for V initial plus negative 9.81 times 0.55, and we end up with V final equaling negative 5.39 meters per second. So I'll write that down in here. And it's negative because the ball is traveling downward in the direction opposite of y, going positively up. So that's what makes it negative. And that is how you physics out the tennis ball dropping.
Now to talk about work and energy. Work is a force applied to an object over a distance. And energy is the ability to do work. Work is equal to the force times the change in distance. If I push this 23 kilogram box, let's say we're going to start from 10 yards, and we're going to push all the way up to 70 yards. You could find out work by finding out that this box was pushed 60 yards and I exerted a force of 25 newtons. Finally, with energy, you can figure out many things at once. So, if this box is starting from rest, it has 0 energy because this is my starting point. If the top of this box's pendulum swing is 5 meters above its resting point, then you can find how fast this box has fallen if it's 23 kilograms. Being as though energy is conserved, the beginning energy will equal the final energy. So I figured out that I start with GPE and then I end up with KE. So if I go through all of my math, I realize that my final velocity is 9.9 meters per second at the bottom of its swing.